Hi, my name is SLC from singaporestudent.com. Thank you for watching this video. So what I want to explain to you today is how to draw a graph of ionic radius against element, or ionic radius against the number of protons. So this is the second part of this series. The first part is atomic radius against the elements or the number of protons that we did yesterday. So before we continue filling up this table and drawing the graph, there are several things you must prepare. Number one is you need to download this pattern from singaporestudent.com. You're going to find the link beside the link to this video. It's very important. You're going to fill up this table and draw the graph. And on another file next to it, you're going to have the answer key. This is the graph, how the graph look like after we finish filling up this table and drawing. Right? So this one is on another file. Also, on the same file, you're going to see the answer. The one that we do now is the ionic radius against elements, right? So after you prepare all this, then we are going to fill this table now. You need to prepare pencil also, and green and red marker, right? To draw the graph, we need to fill up the first 4 rows. We are going to ignore the last row here. Electronic configuration have very little effect on the ionic radius, so we just take care of the last two, which is effective nuclear charge and the number of shell. The first 2 rows is to help you calculate the effective nuclear charge. The first step that you need to do is filling up the name of the elements. I already fill up all this. I leave it empty. You might need to check on your periodic table to be able to do that. And don't forget to put the charges, because we are drawing the ionic radius. So we need to write down the charges of all the elements here. H is +1, lithium is plus, beryllium is 2 plus, boron is 3 plus, carbon is 4 plus, and so on. You're going to have silicon 4 plus and phosphorus 3 minus. Yeah, that's how you fill up the name of the element or the ions here. The next step is to fill up the number of protons of each element. This is of course very easy. You can look up on the periodic table, or even if you do that, you don't have to do that also, because it's in sequence. So it's start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the ions that we are going to put into the graph is from H plus all the way until Ca2 plus. So the proton number is from 1 to 20. There will be electrons on these ions. Some of the ions are on the inside. The valence electron we don't put into the second row. Like this hydrogen here, hydrogen H plus, don't have any electron, so the inner electron also 0. And it will be all 0 all the way until carbon 4 plus here, because from helium to carbon total there will be, each of them will have 2 electrons. and these 2 electrons are on the first shell, which means there are no inner electron at all. That 2 electron is counted as valence electron. So we are going to put 0 from helium to carbon 4+. Starting from nitrogen 3- all the way until silicon 4+. Each of them have 10 electron, and there will be 8 electron on the outside and 2 on the inside. So the one that we write down is just the inside, so we fill up with 2 here from nitrogen all the way, nitrogen 3- all the way until silicon 4+, and phosphorus 3-, P 3- all the way until Ca 2+. Each of them will have 18 electrons. 8 will be on the outside, 10 on the inside, so we are going to fill up 10 here. The purpose of filling up this the first 2 rows here is to calculate for the effective nuclear charge. The meaning of this effective nuclear charge is a rough estimate on how strong the electron is attracted to the nucleus. In our case, we just minus away the number of proton and with the inner electron. So it's easy for us to do. So you just minus the first row, subtract the first row with the second row. So 1, 2, 3, 4, 5, 6. So the effective nuclear charge will be increasing from carbon all the way to silicon. Sorry, from nitrogen 3- to silicon 4+. So 5, 6, 7, 8, 9, 10, 11, 12. From phosphorus 3- to Ca2+, the number also will be increasing. So we minus away. So 5, 6, 7, 8, 9, 10. Of course. The fourth row is the number of shell, which is easy for us to do also. Hydrogen don't have any shell because the 1 electron is taken out. From helium to carbon 4+, there will be they will have 2 electrons each on the first shell. So they have only 1 shell. From nitrogen 3- to silicon 4+, each of them have 10 electrons, 2 on the first shell, 8 on the second shell. So they have 2 shells. From phosphorus 3- all the way to calcium 2+. All of them have 18 electrons each. 2 on the first shell, 8 on the second shell, and 8 on the third shell. So they have 3 shells. Now, how do this number affect our graph? Very simple. Very simple. The more shell you have, then logically the radius of that ion will be increasing. So the effect is very significant. So from carbon 4+ to nitrogen 3-, there will be a very significant increase in the ionic radius. So this green arrow represents a very big increase in ionic radius. So this one. So from carbon 4 plus to nitrogen 3 minus, there will be a big increase there. How about the effective nuclear charge? This thing will also affect the ionic radius. The higher the effective nuclear charge, the more strongly attracted the electrons to the nucleus. So it tends to be, the higher the effective nuclear charge here, it tends to be smaller in size. So from we are going to skip H plus. From helium all the way to nitrogen 3 minus, there will be a decrease in size, a gradual decrease. All the way until carbon 4 plus, there will be a gradual decrease of ionic radius. So similarly, there will be a gradual decrease of ionic radius from nitrogen 3 minus to silicon 4 plus because of the increasing effective nuclear charge. And the same explanation is applicable from phosphorus 3 minus to Ca2 plus, gradual decrease. So this red marker represents a decrease. So it's this green arrow represents a very significant increase in ionic radius. So very simple. We draw a significant increase here from carbon 4 plus to nitrogen 3 minus, and we apply the same method from silicon 4 plus to phosphorus 3 minus. Starting from helium, it will be a gradual decrease. Starting from nitrogen 3 minus, there will be a gradual decrease of ionic radius. And also starting from phosphorus 3 minus, there will be a gradual decrease also. The reason is because you have increasing effective nuclear charge. We can provide the explanation also here. This is because you add more shell. So if you do it correctly, you will get something like this. Yeah, this is a graph, right, of the ionic radius against the elements. Now, hopefully my explanation is useful for you. If you still have difficulty, you can come to my trial lesson in Bukit Batok Street 33 on Saturdays. You can also check my website singaporestudent.com or call me at 90885633. Thanks for watching my explanation. Thank you.